So far we've talked about the exact values of whole numbers. Now let's take a minute to talk about how to get a nice approximation of a whole number we have. We're going to talk about a technique called rounding. Now if we have the exact value of a whole number, why would we want to do this? Well, consider these two whole numbers. 24,802,006,524 versus about 25 billion. Which number is easier to take in? Well, this one is, right? Sometimes you don't care that you have exactly 24,802,006,524 spiders crawling up your leg. Sometimes it's enough to know that you have about 25 billion spiders crawling up your leg. We're going to use this technique especially when we're trying to get an estimate of about what our answer should be in some of the more complicated computations that we're going to do shortly. So this technique, rounding, what is it? Well, there are actually three forms of rounding. We can always round up, always round down, or we can round to the nearest. Now this third form, round to the nearest, is what we're going to focus on. But I'm going to mention again that these other two exist at the end of the video. So, round to the nearest, what does this mean? Well, we might be given a number like 306,212,580. We might be asked to round this to the nearest 100,000. What does this mean? Well, looking at this number, let's find the 100,000s place. Units group, thousands group, 1,000, 10,000, 100,000. Okay, so here is the 100,000s place. This number, then, this is a little bit more than 306,200,000. But then, what if I put another 100,000 on that? Well, 200,000, next comes 300,000. This is a little bit less than 306,300,000. When we say round to the nearest 100,000, we mean this number is between these 200,000s. We want to round to whichever one it is nearest to, that is, it's closest to. Well, what would be halfway in between 306,200,000 and 306,300,000? Right. Well, let's think about this next digit, right? The next digit could be anything, couldn't it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Halfway in the middle, well, 5 is in the middle. The number halfway between these two, 306,250,000. If our number is smaller than this halfway point, we'll round it down to the previous 100,000. If our number is bigger than this halfway point, we'll round it up to the next 100,000. But remember, when we're comparing two big numbers, all we want to look at is the first place where they're different. So, of course, because of the way we picked these numbers, the first place that these two will be different is in this place to the right of the 100,000, so in the 10,000s place. So if the next digit is less than 5, as it is in this example, we'll want to round down to the previous 100,000. Our answer here is 306,200,000. If this next digit had been more than 5, of course we would have been bigger than this number. If the next digit is more than 5, right, then the number we started with will be bigger than this middle number, So we'll want to round up to the next 100,000. What should we do if the next digit is exactly 5? Let's take a look at another example. Let's suppose we wanted to round 682,512 to the nearest thousand. What thousands is this between? Well, this is a little bit more than 682,000, locating again the thousands place, and a little bit less than 683,000. That middle point again will be 682,500. All right, so here, that next digit that we looked at last time is a 5. Oh, but these still agree. So we'd need to go on to an extra digit. This digit is 0 and this is 1. So this number with a 5 in this next place is still bigger than the middle point. The only way it wouldn't be bigger than the middle point is if these were both zeros, so it would be exactly at the middle point. But that's hardly ever going to happen. So we're going to, in making this rule, ignore that possibility. If the next digit is exactly 5, normally that will still mean we're bigger than the middle point. We still round up. By convention, then, if we happened to have exactly the middle point, we would still round it up. So, okay, let's do a couple of examples of this process. Let's suppose we have the number 87,209,000 nothing, and we want it to round it to the nearest 10,000. Well, again, we'll first locate the 10,000s place, units group, thousands group, inside the thousands group, ones, tens. That's tricky. There's a 0 there, but that's okay. We want to think, what 10,000s is this between? Well, this is a little bit more than 87,200,000, no 10,000s. Right? This number agrees with this one, at least until the 10,000s place. And it's a little bit less than 87,200,000 and 110,000. So these are the 10,000s that this number is between. In order to decide which way to go, we look at this next digit. This next digit is a 9. Oh, that means 9 is bigger than 5, so that means this number is past the halfway point. Our answer, we'll want to round up. We'll get 87,210,000. I'm going to give you one of these to try. Round 59,983 to the nearest 100. Pause the video and try this now. Okay, well, first we'll locate the hundreds place. Right. In the units group, ones, tens, hundreds. So this is, well, it's a little bit more than 59,900. What's 100 more than this? Well, after 599 comes 600. So the next 100 after this is 60,000. If we round down, we'll get 59,900. If we round up, we'll get 60,000. How do we decide which one to do? Well, again, we look at this next digit. Bigger or smaller than 5? Well, it's bigger than 5. All right, this is an 8. So again, this is closer to 60,000 than it is to 59,900. Our answer is 60,000. I'm going to have you try one more. Round 291 to the nearest 10. Pause the video and try this now. Okay, well again, first we locate the tens place. Here it is. So this number is between 290 and what's 10 more than that? After 29 comes 30. So this number is between 290 and 300. How do we decide which one it's closer to? We look at this next digit. Is it bigger or smaller than 5? Well, this is smaller than 5, right? So this number is closer to 290. Notice, in rounding, all of the action happens at the named place, in this case tens, in this case hundreds, and the place immediately to its right. Places to the left of the named place, well, strange things can happen to them, but always as a result of increasing the named place. To the right of the named place, our answer is going to be all zeros. So, all of the action happens looking at this place and the place right after it. This digit, never going to affect which way you round. This digit, never going to affect which way you round. You also want to make sure that in your answer, you always have all zeros after whatever place we've named. Now, I said that there were actually 3 kinds of rounding, right? I said that there was rounding to the nearest. That's what we've been doing so far. Sometimes we might want to just always round up. We'll want to do this if an underestimate is super bad, but we don't care about overestimates. So for example, if we want to round 8,212 up to the next 100, well, 8,212 is between 8,200 and 8,300. The next 100 will be 8,300. Sometimes we want to always round down. So for example, we might be told to round 53,210 down to the previous 10,000. Well, this is between 50,000 and 60,000, thinking about the 10,000s place. The previous one, it's just 50,000. So if our instruction already tells us to round up, or tells us to round down, or in real life if we have reason to always round up, or reason to always round down, well, the problem is even easier, because we don't need to think about which one is closer. We'll always take either the next such and such place, in this case the next 100, or the previous such and such place, in this case the previous 10,000. Another kind of instruction that we might encounter for rounding, and one that's going to come in really handy, is to round a number so that it has at most a certain amount of information. So we might say, for example, round 829,501 to have at most one non-zero digit. Well, of course, we only get rid of digits to the right of the place where we're rounding. So to have one non-zero digit, that means we want to round to this first place. We'll want to round to the nearest 100,000. All right. So this number is between 800,000 and 900,000. Looking at this next digit, a 2, well, that's closer to 800,000. Wanting one non-zero digit is the most common. We might want to round to have at most 2 non-zero digits. That would be 1, 2. Again, this number is between 560,000 and 570,000. Looking at this next digit, a 1, that's closer to the smaller number. Why this at most? Let's suppose we started with 3,995 and we want to round it to have at most 2 non-zero digits. Well, what place would we have to round to? Right, we would have to round to this place. So this number is between 3,900. Let's see, after 39 comes 40. Between 3,900 and 4,000. Oh, but this next digit is a 9, bigger than 5. So we're closer to 4,000. That doesn't have 2 non-zero digits, does it? Look, of the digits, only one of them is not 0. But that's the best we can do. There's no way we can round this so that it would have 2 digits that aren't 0. This instruction will always say at most. Because sometimes the way rounding works out, you don't end up with that many non-zero digits. I'm going to give you one of these to try. Using the same number, 74,967, round it to have at most 1 non-zero digit, then round the same number to have at most 3 non-zero digits. Of course, these two questions will have 2 different answers. Pause the video and try this now. Okay, so to get at most 1 non-zero digit, well, we need to look at this first place. This number is between 70,000 and 80,000. Looking at this next digit, it's smaller than 5. So this number is closer to 70,000. What about if I round it to have at most 3 non-zero digits? Well, then I want 1, 2, 3. This number is between 74900, 74,900, and after 749 comes 750. So between 74,900 and 75,000. This next digit, well, this is a 6, so we should round up. We get 75,000. And again, we don't actually have 3 non-zero digits, but it just didn't work out that way.